Hello again, so we have reached exercise 12, which is hashing with Q. So we consider a hash table T of M, where M is a constant. So the collisions are handled by separate chaining. So if the element collide, so we'll add them to a queue. So we need to give the declaration of the data structure to use, and then we need to write the function to add an element to such hash table. So we have the hash table, which is here. So it contains m elements, so from 0 to m minus 1, and each element it contains a queue. So let's take one cell here. So we have this cell at index, let's say L. So here we have a queue. Inside of the cell we have a queue. So it's an array of queues. So what we'll do is that we will be using a queue. So we need to first give the declaration. So of course a hash table is an array of queues. So we have integer elements, so we have the typical declaration of a queue. However, a hash table, it's an array of queues. It's an array of m queues. So I have wrote here the test, the main function. So we declare a hash table, so we need to fill the hash table. So we need to fill the queues. So they are empty, so we need to create the queues, and then we will read some elements from the keyboard, and then when we reach 0, the last element is equal to 0, I will stop. However, for each element that I will read from the keyboard, I will insert it into its corresponding queue. So of course the insert can be done or cannot be done, since we are using a static implementation of a queue. So if the queue is full, I cannot insert the element, and then I will print the hash table as it is. So to create a hash table, and since the hash table is an array, so I have passed the hash table by parameter. So I just need to loop over the array in order to create each of the queues. So here I just need to loop from 0 to m I plus plus, and then I just need to say h of I is equal create a queue, since I need to just create the queue. And this is it for the creation. There is nothing to return. So for the hash function, so we will use n modulo m. So n is the number, and then we will hash it. M is the size of the hash table. So to insert an element into a hash table, I have the number here, the element I need to add. I will hash it. I know the index, and then I just need to enqueue it in the corresponding queue. So it's easy. It's just one sentence. It's return. I will enqueue the element NB into which queue. So it's h of which one is the hashing of NB. So hash of NB. So whenever I call hash of NB, I will get an index. For example, if I get 5642, if I hash it, I will get 2, and then I will add it to this queue. So I need to use an address, because enqueue takes an address. So and then we need to print the hash table. So I will do that. So I will loop over all the indices, and I will print this. So for I equal to 0, I less than m, I plus plus. So I will print index percentage I, and then we will need to loop over the queue. So while front, so the queue here is h of I, and we need an element. So address of NB, and here we need an element. We will dequeue it, and then we will print the element. And let's add \n in order to go to the line after each insertion. So again, here, if you have done some of the previous labs with me, so you know that whenever we do that, since we are dealing with arrays here, so we have the address. So whenever we are dequeuing the elements from the original array. So if you want to keep these elements, you need to do the copy the queue, and then loop over it. So let's run it and see if we will have the same output. So yes, we had the same output. So we have 4 elements, and we have done this using hashing that resolves the hashing using queue. So this is it for this exercise. So it's just a one sentence solution. So if you have any questions, do not hesitate to write to me, and I will answer you back. And again, thanks for watching.